So you see in projection welding, right, as the name suggests, a dimple is produced on the workpiece, right? You see, you have one welding plate and the other welding plate, right? You will have this dimple produced intentionally. So when this electrode, these flat electrodes will try to press it, these dimples, right, from on one welding plate will try to come in contact with the other plate, right? So basically when they contact there, you have a spot weld created, right? As you can see, flat electrodes, right? They are only responsible for bringing these plates together. And the passage of current is to be taken place from one plate to the other, right? Through these dimples. So wherever it is contacting the other plate, a spot weld is created because of the resistance, right? So this is also another type of welding, projection welding under resistance welding. Okay. You see flash butt welding. It is used to weld tubes and rods in steel industries. The workpieces are clamped in the electrode holders. You see here, this one is a fixed electrode. The other one is a movable electrode, right? This will move left and right. High pulse current in the range of 1 lakh ampere, right, is passed. The electrodes, one is fixed and the other is movable. So you see here that current, right, will cause it to form a weld. Okay, this is why it is used to weld tubes and rods, right? So a lot of current is required so that those joints are created, right? Weld tubes and rods in steel industries. So this is called flash butt welding. Okay, because they are having a butt joint, right? And because of this flash of that high current, we call it flash butt welding. As for the applications, resistance welding, as I said, automotive industries. And that video, I believe, will give you an idea of this automotive, how is it used in automotive, that sheet metal components. You have projection welding for production of nuts and bolts, right? Seam welding for producing leak-proof joints is required in small tanks, boilers, etc. Right? Because that if you have observed a pressure vessel, you will see that continuous weld spot, right? Continuous weld line. But that is basically your seam welding, right? Done through seam welding. Flash welding, welding of pipes and tubes, as we have discussed, right? As for advantages, you can weld thin of the order of 0.1 mm as well as thick, right? As thick as 20 mm plates also. High welding speed, right? Easily automated. This can be automated very easily. You just have to have that, that setup or the arm, right? Or the electrodes, if you want to call it. The electrode setup has to be at the proper location, right? It has to be brought to the proper location. That can be done with the help of an automated system, right? So this is very easily automated. Both similar and dissimilar metals can be welded, right? This is one particular advantage. Process is simple, fully automated, and it does not require high skilled labor, right? Because you are able to automate it. That makes it that simple and skilled labor would not be required, right? But this also comes off as a disadvantage, isn't it? That you would have unemployment rates and the skill would not be passed on from one generation to the next when you're trying to automate it, right? So that also is one factor. High production rate, right? It is an environment friendly process, right? Not much of arcs are generated. It does not require any filler metal, flux and shielding gases, right? No shielding gases, no flux, no filler metal. Only that resistance is there in between the two weld metals, right, is responsible for creation of that weld nugget, right? Disadvantages, the equipment is high cost. The thickness of the workpiece is limited due to current requirement, right? Because more the thickness, more is the current requirement, right? more current would be required to jump that gap. So that is limited, right? Thickness of the workpiece. Even if it is high, you will not have complete weld, like that weld nugget will not be completely fused. So that will lead to a weaker joint, right? It is less efficient for high conductive materials, right? Because if it is conducting, then there will be no resistance, right? Or lesser resistance. So this is why this is a major point you can say. For conductive materials, this resistance welding will not do good, right? Will not perform as you intended to. But for lesser conductive materials, yes, this is one of the best processes. High electric power required, right, for creation of that resistance. Weld joints have low tensile and fatigue strength, right? This is also another disadvantage. Because you would have those spots, they will act as stress concentration, right? And therefore fatigue also is affected. You see, that video will clarify. I think, should we watch the video? I did not convert it to hyperlink. So let us just directly go to.
With the RockLock Quick Change system from 5th Axis, you can simplify your programming.
Right, let us see the yes, the principle.
Resistance is the property of the conductor, by the virtue of which it resists the flow of electrons, that is the flow of current through it. This resistance to the flow of electrons creates friction and heat. This heat generated is then used to join the two similar or dissimilar metals by melting and forming a bond between them.
Remember, it is not melting, okay? They're brought to a state wherein they are softened, right? They're in a plastic state, right? So that if you press them together, they will fuse and form a joint. That's how it works, okay? They're not melting.
Types of resistance welding processes. 1. Spot welding. 2. Seam welding. Spot welding. Spot welding is also known as the resistance spot welding process. It is used to weld thin sheets of metal together by applying pressure. The heat required for welding is generated by resistance to the flow of current through the electrode. Working principle. The welding electrodes are made up of copper, which is a good conductor of electricity. The movable and fixed electrodes of the spot welding machine are held in pressure on either side of a pair of plates to be welded together. As the current passes, it experiences the resistance between the electrode and workpiece contact and generates heat. This heat causes the interface of the workpiece in contact with another workpiece to melt, and pressure fuses the two metals, thus forming a solid bond.
You see that pressure is also important, right? Once they are brought to that plastic state, wherein they are softened, you have to apply some pressure so that they get joined at that particular location, right? They're fused. So that application of pressure is also important. Not just that, it's not that they are only there, the electrodes are only there to supply the current and create the resistance. They're also responsible for creating that pressure. Once reaching the plastic state, softened state, these electrodes will push them so that they join, right?
If you are enjoying this video, Please give this video a thumbs up to get more information. Tongs, also known as electrodes. Working of spot welding. When the power is turned on, the transformer supplies the low voltage high current to the electrodes made up of copper. These electrodes are held in pressure against the pair of workpieces to be spot welded with the help of tongs. The current flows from the tongs to the electrodes, as copper is the good conductor of electricity but faces resistance at the point of contact between the two workpieces. This resistance generates the heat at metal-to-metal interface and causes the two metals in contact to melt. Then the pressure causes the molten metal to fuse together, and thus a solid bond is formed. Application of spot welding. Spot welding is used for welding thin sheets together. In the manufacturing of fuel tanks, joining vehicle body parts, radiators, wire ends, etc. Advantages of spot welding.
Right, we have seen these things, right? Just wanted to have a look at the principle and how that resistance is generated. Okay, a 3D view. Is that clear? Or are there any doubts? Okay. So you see, that was your resistance welding. You see, coming to another type of welding called thermite welding. Okay, thermite welding. You see, it uses what is known as thermite or thermite. Okay, it's a type of fusion welding process. It is also known as exothermic welding or bonding. Okay, the reason why it's called exothermic welding is because you have a reaction taking place, right? Because of the chemical reaction, heat is generated, right? Certain compounds are mixed, and there is an exothermic reaction taking place. So that's why you got it exothermic welding also, or exothermic bonding also. This process is used for welding large and heavy structures, right? As for example, rails. We'll see that in the video also, that rails and any other machine, for example, ship structures also. For large and heavy structures, you will go for thermite welding, and even for remote areas, right? Areas where you cannot take that arc welding setup or resistance welding setup because current or electricity would not be available at those remote spots. So you have to go for these kind of welding, right? That is thermite welding. It uses some compounds, right, which you can transport it, right? Those can be transported to that spot, and once they're ignited, that welding will take place. We'll see how. Other point is it requires no electrode, right? Electrode is not required, and power supply is also not required. That is why I said it can be used for remote locations wherein you don't have power supply, right? You are not able to access power supply, and also another point is it requires no electrode. The principle is, in this process, the welding is done by pouring superheated liquid steel around the parts that are to be joined, right? So how you create that superheated liquid steel is through that exothermic reaction, right? We'll see how. But what is happening is you are melting that liquid steel, right? Superheated liquid steel, and you are supplying it to the around the parts that are to be joined. Okay. A short molding process is to be done before welding, so that you have that gap created, right? So what is thermite or thermite? It is a mixture of fine aluminum powder and iron oxide. That is a mixture, right? I was talking about. That produces a very high temperature on combustion. You are trying to ignite this mixture, right? Used in welding and for incendiary bombs. Now the thermite reaction involving aluminum is also called as Goldsmith aluminothermic reaction if it involves aluminum. Okay. Usually this reaction is triggered by burning magnesium ribbon in presence of barium peroxide, right? How you trigger that reaction so that this it gets into combustion is with the help of a magnesium ribbon. You are trying to burn that ribbon in the presence of barium peroxide, right? So as for the composition, by weight we are adding 75% of iron oxide and 25% of fine aluminum powder, right? Fine aluminum powder and iron oxide should have a ratio of 1:3 by weight, as we have seen here, right? We can also use copper or chromium instead of aluminum. That is also done. Working, the end bars have to be joined are kept parallel with uniform gap between them, as I said. For example, the joining of two rails, you will keep some gap between the two rails, right? And then the gap is filled with wax, which becomes a pattern, right? You'll fill that gap with wax, and then you will what do you call, ignite the mixture, right? Molding sand is rammed around the wax pattern. Pouring gate, heating gate, and risers are cut, right? We see here. This is what we are talking about: riser and gate, right? All of these things. So what is happening is these that mixture of aluminum and iron oxide is burnt here, right? When it burns, it creates that molten metal, right? This is a tapping pin which will release that molten metal, and this whole setup which we have created, right? The runner, the gate, the riser, etc. This is basically surrounding the parts that have to be joined, right? We have talked about the gap, right? So this molten metal will flow through this runner to the gate or to that gap we were talking about, right? So you see this with the help of this torch, preheating is done. This is called a preheating gate. So once before releasing this molten metal, because when the molten metal reaches here, this is at a room temperature. This is at very high temperatures, maybe 1000 or 2000 degrees centigrade. So this will cause some kind of temperature difference, right? Temperature gradient would be there. It might lead to cracks, etc. So this is why this preheating is done with the help of torch, right? So once you have preheated it, brought it to certain temperature, and then this molten metal will be sent through this runner, the gate, and then it will come to that gap, right? It will fill the gap, and therefore joining the two components which are to be welded, right? The sections to be welded. And once it fills the riser, right? Once that is filled inside, it fills the riser, and just as you have seen here, there, this riser will supply the molten metal for shrinkage, I mean to avoid shrinkage, etc. Right? That is what is happening. So the joints to be welded are preheated, as I said, with the external source, flash, etc. Due to preheat, the wax melts and goes out. Right? That wax which was there earlier, it melts and goes out, and also that whole setup reaches a certain temperature, right? Preheating. After melting of wax, weld joints are preheated, as I said. Then heating is stopped and the heating gate is closed, right? And then you will pour that mixture. I think we should look at this process in the next class. It's already 9, right? Yes. So if there are any doubts, you can ask. Meanwhile, I'll take the attendance. Any doubts? We've discussed part of thermal welding, we've discussed resistance welding, we've discussed submerged arc welding also in today's class. Okay, then if there are no doubts, then we'll end the meeting. Thank you.